All right, we're going to take a look at the virtual day problem you had and just expand upon that. So you actually had to calculate some of these values. I have the completed table that you guys had to do. And you were asked questions about the vertex. We first said that the vertex is the lowest point on the graph. So then you guys had circled this point and noticed that this was the vertex. In the table, it is also where the points start to mirror. So if we go back to the table, this was our vertex here, because we can see that the points start to mirror. You can see the 0, the 0, the 3, the 3, the 8, the 8, and so forth. You then were asked how you can see the y value change. And some of you were really clever with your answer. Some of you said you add odd numbers, which is what happened, or you added 1, then increased by +2 each time. And so that's what we saw here. We went from the vertex, we went +1 in both directions. And then for those who said the odd, you're like, oh, 3 would come next. And then 5 would come next. And 7, and that worked in the other way. +3, +5. And then we could keep that going. That is the pattern of x squareds. Or some of you recognize that, oh, my numbers increased by 2. So there were like 2 patterns going on here. We also can see that in the graph by seeing that from the vertex, we built up and out by 1. Then from those points, we built up by 3 and out 1. And then we went up by 5 and out 1. So the out number is always by 1. But then we call those like the building numbers. The growth in the y was by the odd numbers. And so that is the other place we can see our mirroring take place, is that if you draw this like a ladder, our points make the rungs of the ladder. We can see that they're directly across from each other. And this kind of symmetry is kind of going through them. A lot of things we saw in the virtual day lesson. We are going to specifically talk about quadratic equations. And those are equations that have x squared in them. So we did a factoring unit. Factoring will come back to this later. But for now, you see an x squared, it's called a quadratic equation. When graphed, they make a parabola. Sometimes they smile, and sometimes they frown. So if you remember, we did this back maybe August, September time, parabolas are the graphs that look like U's. They can look like that or that. Now our standard form of a quadratic equation is actually what we saw a little bit with factoring. Y equals ax squared plus bx plus c. And we have seen those terms before. If we look at the a specifically, if the a is positive, it's going to smile. And if the a is negative, it's going to frown. We do have a formula for the vertex so that you don't have to graph a bunch of points just to find it. The formula for the x value, this is only the x value of the vertex, is the opposite of b over 2a. And notice I said that this was the opposite. Because if b is negative, and again, we're looking at the b here. If the b is negative, we say the opposite, so it would be positive there, and so forth. So using what we know, let's graph this quadratic equation with some of those shortcuts we found. It would be helpful to find the vertex first so we know where our symmetry starts. And so if our vertex is the opposite of b over 2a, our x squared would have an a of 1, and our b is the x term. So our b is 2. So if we substitute opposite of b, b is 2, so the opposite would be negative 2, all over 2 times our a value. This gets to be negative 2 over 2, which is just negative 1. Now remember, this is only the x value. So we know with this little formula, it's negative 1. There's really no shortcut for the other way. We just have to plug this in to find the value of y. So y equals our x value squared. Remember, any number we substitute, let's throw in parentheses, that matters in a moment, especially because our x value is negative. So when we do this and we follow our proper order of operations, we take care of our exponent term first. And remember, when you square something, it's that number times itself. And so be careful, it's negative 1 squared is actually a positive 1. A couple of you were putting negative in your virtual day assignment. So remember, anytime you square something, it's positive. Then we can multiply next. And then now we just work left to right. 1 minus 2 will get us negative 1. Minus 15 gets us negative 16. So this is the y value, right? If we bring down our y equals, this is the y value of the vertex. And now we can go ahead and graph that. We said that our building numbers go up by the odd number. So we'll build up by 1 in each direction and go out 1. From those new points, we go up 3 for our next pattern. So up 1, 2, 3 and out. And then this one mirrors it. Then we go up 5. And we mirror that. And you're going to keep going until you can't fit any more points, up 7 in each direction. And then finally, we run out of room by going up 9. But by recognizing the pattern, this is actually a really quick problem to graph. As for the table then, what I like to do is put our vertex right in the middle of the table. Our x will grow by 1 in each direction. In this pattern, x just has a constant of 1. And then we can use our pattern of the odd numbers. So first we grow by 1. So we add 1 to our negative 16, and our negative 15 mirrors over that. We can see that in this set. Then we add our 3. And so negative 15 plus 3 puts us at negative 12, and that mirrors here, and we can see that in this y value. And we add our 5, so that gets us to negative 7, and that mirrors with a negative 4. And so we could keep our table going. So it really just started with the vertex, and then recognizing the pattern of how y changes. And we didn't have to do a lot of math with substituting values in for x. We just used our pattern of what we know about quadratic growth to fill in our table there. Let's try again with this equation. Now, something I want you to note is that our a term is negative. So because it's negative, that one is actually going to be a frowning parabola. So let's do our process of finding the vertex first. And I want you to use your formula and try it yourself. You can go ahead and pause the video and play it when you're ready to check your answer. Okay, what I want you to be careful of, pay attention that it's a negative x squared. So what that is saying is whatever you get for your x squared value, I said before x squared is always positive. But if there's a negative in front, you want the opposite of whatever value you get. So when you square negative 1 here, you do get positive 1, but you have to bring down that we wanted the opposite value because that negative was not part of the parentheses. So hopefully you can follow that and see how we got 9. And what changes here with this frowning is instead of building up by our odd numbers, we are going to shrink by our odd numbers because our A term is negative. So in this case, we're going to shrink by 1 in each direction. We're still going out by 1. We'll shrink by 3 in each direction, and this one will mirror it. We'll shrink by 5 in each direction. And we'll keep that pattern going for as many spots as we can fit on our graph, and actually this is where we end it. So this is our parabola. I'm fine if you leave it like that. If you want to erase the inside of the parabola, you may do that as well. And now when we fill in our table, we can sneak our vertex right in the center. And then we know that our building numbers actually shrunk this time. So instead of +1, we decreased by 1. And our x always increases, our x pattern is always by 1. Okay, so we go up the next one. Now we went down 3. We went the next odd. So 8 minus 3 would get us to 5. So we would mirror our 5 here, and we could expand our table even more. But we could see those values actually reflected in our parabola there. All right, use what you saw in the last 2 examples to try this one on your own. Go ahead and pause the video and play it to check if your parabola and table are correct. All right, go ahead and check your parabola and table and see how close you got. As for the next question, I am running out of time in this video, so we will skip this one. So go to the final page with our table. We've learned several patterns this year that make different graphs. So in the linear relationship, you added a constant value to your y. So our equation was y equals mx plus b. And when we graphed it, it just looked like a line. So we can tell that this table over here is linear because when we go from this y to the next one, we add 4. We add 4. We add 4. We can see the consistent adding of 4, and that makes something linear. Last chapter, then, we learned about exponential, and that's when we multiplied a constant value to y. That equation took on the form y equals ab to the x, and it started off growing really slowly, and then it grew really fast. It was kind of that curve. And we can tell it's exponential because here we went times 4, times 4, times 4. There's a consistent multiplication of the same value. And finally, our quadratic is when you add 1, add 3, add 5, the odd numbers, y. It takes on the form y equals ax squared plus bx plus c, and it makes a parabola. And you'll know it's quadratic if you can find where it mirrors, which in this case is our origin, and we can see the +1, +3, +5 in both directions. Okay, at the bottom, use the patterns from above to determine which one is linear, which one is exponential, and which one is quadratic. Pause the video and play to see the answer. All right, there you have it, our 3 different kinds of patterns we've seen so far this year. Okay, well, thank you for watching and have a great weekend. I will see you guys on Monday.